Welcome to Fun with Data. I'm Marcel-Jan, and in this video we're going to have a look at a graph database. It's called Neo4J, and we're going to put some rocket data in it. So Neo4J, what is that? Well, I read about it in this book that I reviewed a couple of months ago, 7 Databases in 7 Weeks, 2nd edition by Luke Perkins. And one of the databases they described, they have 7 completely different types of databases. And Neo4j is a graph database, and it's all about relationships between the data. And I could tell you about how that works, or I could show you, and I'm going to show you. So here we are in Neo4j, the desktop application. We have a database with movies, actors and directors. And here are all the movies that Matthew Broderick has played in, and the actors that also played in those movies. We can have it in JSON kind of form, we can have it in table form, but much more fun is the graph form. And there we are. So the gray circles are the actors and directors, in this case only actors. The red circles are the movies. We have a red ball with the producers, and you can see they move like there's some kind of force field between them. And we're gonna have a look for one particular movie I like, and it's called Ferris Bueller's Day Off from I think 1984. And yes, there we have it. You don't see it yet, but when you look underneath and the line underneath, you can see there it is. The title is Ferris Bueller's Day Off. So you can see these nodes, these circles are all nodes. They all have they can have some information extra in them. So let's drag it out. Let's expand everything we know, all the relationships we have on this. And we see there's also a director, John Hughes. And you can do something similar. You can keep expanding as long as you have more relations left. Just like, for example, let's have a look at Charlie Sheen. He played some kind of arrested teen. Well, he has played in a lot of movies, other movies, and you can also immediately see all the other relationships between the other actors that were already in our graph, and so on. And you can keep going on with that and that. And of course, you can nicely collapse all that and make it sort of tidy. So that is how graphs look in a graphical sense. So what are we going to do with this? Well, what can we do with this? Well, we can use this, we can use graph databases for a couple of things. You can make recommendation engines with graph databases. So these are these people who bought this, also like that kind of affairs in websites. You can have a look at all the systems in a network and see any relationships between that. You can have a look at relationships between Wikipedia pages. And a special example of the use of graph databases has been the analysis of the Panama Papers, where you could see who was beneficiary in certain schemes in ways to avoid paying taxes and that kind of stuff, which was an interesting one. So what are we going to use graph databases for? Well, what I've been thinking, I mostly like astronomy and space related data teams, and it was a bit hard to think about what kind of many-to-many relationships I could use in a graph database. But at a certain point, I ended up at this old favorite of mine, Jonathan's space page. And you might not know it, but this page, now it's a page, it used to be on Telnet or FTP or something, is maintained by a guy called Jonathan McDowell, and he has maintained a list of orbital launch logs and satellites since a long time. And we're gonna download these lists and use them in a graph database. But we need to do some extra stuff. We need to work on the data a little bit, because here we are. Here is the launch log of Jonathan's space page, and it looks all good, but when you look at the rocket launches where multiple satellites were launched, you can see there are empty fields. And Neo4j doesn't like the empty fields. Well, you can do stuff with it, but I wanted to have these empty fields filled with the same data as the first satellite in the launch log on the same rocket. So what I've done is I've used Python and pandas. Yes, it's still a favorite of mine. And I've loaded the file and loaded it with pandas and used the forward fill function, which is very cool because it will let you to fill the empty fields with the fields preceding. So now we can have exactly what I want, have the same launch time, same launch designation in the satellites on the same rocket launch and fill all these fields up. So there's that. Now, what I did is I created CSV files of these. So before you can load them, well, I had to put them in a special import directory of the Neo4j database. I tried to point to other directories that didn't work. So this is how I got them loaded. And now we have the little matter of defining a graph model. Because these are about relationships, so loading this is different than your regular relational database. So here we have, for example, the launch log. We have in the launch log data a launch site, launch outcome, a launch vehicle, even a launch vehicle type. And we have to match that launch log to a satellite. And this, in the satellite data, there is an owner and there's an orbital type. So when we load the data, we need to define these relationships. And I did that. So this is how it looks like when you load CSV data in Neo4j. The language is called Cypher. I'm not gonna explain every nitty-gritty about this, but what's happening is we load a CSV file in a row and then we describe what parts of the row needs to go as attributes of a node, and we define a satellite node. Now we do the same with the launch log, and now we need to match these up with a match command. Here you see that we have the satellite node and the launch node, and we say, just like in SQL, where that one designation is the other designation, and then we merge them, and here we define the relationship, and we call this relationship launched on. And now we have that relation. So after we have this loaded, this is how it looks like. So we start the Neo4j desktop application and we run call db schema visualization. And here you can see that our model is actually there, that all the relationships are there as we want it. And now we can do a query. For example, we can do a query of all the satellites owned by the Indian Space Agency ISRO and all the rockets they were launched on. And boom, there we are. There's a graph. There's ISRO. There are all these satellites. And there we go. And there are the launch log events in the red circles, and the green circles are the rockets. So that has worked pretty well. You can see there are some launches on Ariane 5. There's the GSLV Mark III, which is India's newest rocket and most powerful rocket, and you can expand that and you can do all kinds of stuff. So there we have two types of this rocket, D1 and D2. So that works. Some other queries. Well, let's have a look at all Atlas rocket launches. And here we have a we're a launch vehicle like Atlas, but this is the way you do this in Cypher. You do a is tilde, and then you can use a asterisk as a wildcard. And there we have, for example, well, that's an owner of satellites. But here we have an Atlas SLV3. It's an early type of Atlas. Atlas rockets have been around since almost the dawn of spaceflight. So you can imagine there were a lot of types. Atlas Agena D. It's all from the 60s and all that kind of stuff. So this works also. Let's have a look at all satellite launches with a limit of 100 nodes, by the way, in deep space in orbit type DSO. Oh, we removed the limit, sorry. So here we have all satellites in deep space. Well, not exactly all, because there's also orbit type CSO, which is sort of similar. But never mind. There we have the rockets they launched on. There's a Japanese rocket, H2A. And we have Thor and all that kind of stuff. So that also works good. There's a Molnya, which is a Russian rocket. And that's that. Okay. Now let's have a look at all rocket launch failures with satellites. What does that look like? So we look at the outcome is F, which is how it's called in the data. And we run that, and here are all rocket launch failures, and now you can see what rockets they were launched on. So a lot of red balls. The green ones are the rockets, the launch vehicles. And we see there's an Ariane 5. And it looks like a lot of Ariane 5 launches went southways, Falcon 9. But it's not entirely fair because all the satellites on that launch are called as a red circle in this. So it looks worse than it is. So that is basically how it works, and I have all the code, the Python code and the Cypher code on GitHub, so you can have a look at it and try things yourself and have a little bit fun with it, because I have to say Neo4j is a lot of fun. So I hope you liked this video. If you want to see more, subscribe or read stuff I wrote at my Expedition Data blog. Sometimes I put stuff on Twitter, not always IT related, sometimes astronomy and space related. And there's one thing I have to say. I started working for a new company May 1st, 2019. It's called DIKW, Data, Information, Knowledge, Wisdom. And I have to say, what a change this has been. It's been great to have such a team behind me to help me being as effective as I can be. To have people share knowledge. That is what the DIKW is all about. And if you want to join us, let me know. And if you want to hire me, because I am now available as a consultant, data engineer, then surely let me know.